Hello, my name is Mark Case, and welcome to our first lab that we're going to be taking a look at called the one-tube reactions. In this experiment, we're going to be using some materials that you could find around the home to be able to do an experiment that will observe physical and chemical changes. We'll look at the formulas of the substances that are involved, the chemical symbols used to represent them, and try to determine what's being produced as new products, and it will give you a chance later on to try to separate this mixture that we're going to create and see whether or not they have indeed formed new materials by a chemical process, or have they just dissolved and perhaps formed a physical mixture which we can then re-separate at the end. The experiment involves taking a test tube that you have. You can have various sizes. 13 by 100 sometimes is used if we're having each student create one, or in a class set we might have one. This is a 18 by 150 size millimeter test tube, and what I'm going to do is I'm going to take just a paper funnel that I've created by folding over a piece of paper and use that to be able to add a compound called copper 2 sulfate. Now, copper 2 sulfate is sometimes used as an algicide that you might add to a fish pond to keep the algae down a little bit. Sometimes you have a situation where you might have tree roots that are growing into your septic system. Sometimes it is sold as a root killer to get those out of there. So we're going to take and add some of this copper 2 sulfate, as the name is called, so that our test tube is roughly about 1/3 full of this compound. Doesn't have to be exact, it is an approximation of what you're working with. The next thing we want to do is we want to just take a piece of tissue or a piece of paper towel. In this case, I just have a small square that's roughly about 2 centimeters on each side. And I'm going to put it down inside the test tube and try to force this down so that it will create a layer sitting on top of the copper. Now I'm using a glass stirring rod. Sometimes that's a little challenging, but what has been very useful is to take a pencil and use the eraser, because it gives you a little bit more grip so that you can get this and just sort of push it down in place. It doesn't have to be perfect. It's just trying to create a temporary barrier that will allow solutions to pass through, but try to hold some of the solids from mixing inside there. We're going to then take a little bit of distilled water and add that to it. In this case, you want to add it slowly, let it run down the side, and you might notice that it's working its way down through the copper sulfate. What we would like to do is to have the entire copper sulfate actually wetted by this water that's in there. If it seems to be sticking a little bit, like we have it in this case, what you can do is hold the test tube firmly at the top, and then using your fingers, just tap it a little bit. So I'm just moving my fingers back and forth, and I'm trying to get this to work its way down to the bottom of the tube. It will eventually seep in and work its way down. I'm going to push my tissue paper down again because it moved up a little bit. But that would be our first layer that we'd be creating. The second layer is going to be using ordinary table salt, and the name of this is actually called sodium chloride. We will be looking at that a little bit later on in this course as we're trying to describe what that is. So I'm going to add some of the sodium chloride again to try to see if I can get about 1/3 of the test tube full. Now, you might notice some changes that are occurring in the color of the mixture. We want you to make very careful observations of what's happening during the course of this lab and see what changes are really taking place as this sits here for several days and eventually forms our final products. I'm going to take another piece of the tissue paper and I'm going to force that down into the tube so that it creates a layer sitting on top of the sodium chloride. Sodium chloride is getting a little yellowish green here in the individual reaction. The last thing that I want to do is I want to take either a nail or a paper clip. Paper clip sometimes has a little coating on it, but if you sand it off a little bit with either steel wool or just ordinary sandpaper, what you will do is you expose the bare iron underneath or any other piece of iron that you might have. And we're going to drop that in on top of the sodium chloride layer. And then the final thing we want to do is to just add some distilled water again so that we completely cover whatever iron sample we happen to be using in the process. There should be a little bit of space on top just in case we start generating some gas bubbles that might be created. I'm going to take a little bit of saran wrap or what we sometimes call parafilm, which is a sticky type of material that you could use to put a cap over top of this. This is just sort of a precautionary measure so that this doesn't spill while it sits for the next several days and we go through our individual observations that are going to be taking place. So let me cover this for a moment. You stretch it over the top and then wrap it around so it gets a good seal. You can use 1 or 2 layers. It's not really significant. So as we start this lab and we begin to look at the changes, we're going to ask you to keep a journal daily of what's happened in terms of the different layers that you have. Do you see anything new and different that is being formed in the process? It was a little yellowish color in the salt, but now you might see that there's a little bit more of a darker green that's beginning to form. This is what should be recorded in your notebook. And keep a journal very accurately of what you see as your observations. Now, as far as conclusions go, that would be what you think is happening, what you're trying to interpret, and you can make some predictions about what you think is taking place. Maybe you know, for example, that if you take iron and you put it into a rusty, or excuse me, I sort of gave it away, but you put it into a salty water environment, it's going to begin to rust. So the iron piece that I was using was fairly shiny. It's already starting to get a little bit of a dimming of the shine. The luster is going off of it. So we're going to record this every day. We're going to look at it over a series of about a week or so. And then after that, what we're going to do is we're going to see if we can separate the components of this test tube and find out whether or not we still have any of the copper 2 sulfate left. Is there any sodium chloride? What about the iron? What's going to happen to that? And then we're going to show you how you can use the periodic table along with the general guides for naming compounds in chemistry, that we can represent them by name and also by looking at a chemical formula and writing what's called a chemical equation for the reactions that occur. So make your final observations, write down your notes for your initial setup, and we'll see you later.